addressing direct current, or DC, flowing through the ground on a farm when the source is not immediately apparent requires a systematic approach involving investigation and mitigation strategies. Firstly, finding the source involves several key steps. A thorough inspection of the farm for potential DC sources is crucial. Look for faulty electrical equipment, battery banks, solar panels, or any other devices that could be introducing DC into the ground. Secondly, use a DC multimeter to measure current flow at various points on the farm. Pay particular attention to buried cables, pipelines, well casings, and areas where the soil is consistently damp. These measurements can help pinpoint the areas where the DC current is most concentrated. Thirdly, consider using a Gauss meter or similar device to detect electromagnetic fields generated by DC currents. These fields can indicate the location of the DC source, even if it is hidden or buried. Fourthly, conduct ground resistance measurements at different locations to identify areas with unusually low resistance. These areas could indicate a DC fault or a path of least resistance for the current flow. Fifthly, take soil samples from areas with high DC current flow and analyze them for the presence of conductive materials or chemical contamination. These materials can enhance the conductivity of the soil and facilitate the flow of DC current. If the source of the DC current cannot be identified, measures can be implemented to mitigate its effects, particularly in animal areas. These measures focus on redirecting the current flow away from sensitive zones and minimizing its impact. One approach is to install additional grounding rods around the animal areas. These grounding rods provide a low resistance path for the DC current to flow away from the animals, reducing the potential for it to affect them. Another method is to create a barrier around the animal areas using a conductive material, such as copper mesh or graphite sheets. This barrier can redirect the current flow away from the animals, preventing it from entering their environment. Applying cathodic protection to the affected area is another strategy. This involves installing sacrificial anodes that will attract the DC current and prevent it from flowing through the animal areas. The anodes corrode instead of the structures of the ground in the animal areas. Insulating buildings and equipment in the animal areas is also beneficial. This prevents the DC current from entering the structures and coming into contact with the animals. It is good practice to isolate electrical wiring and equipment in the animal areas from potential DC sources or from each other. This reduces the risk of current flow between different components and minimizes the overall DC current in the area. Here are some additional tips to consider. Firstly, consult with an electrical engineer or geophysicist for specialized analysis and recommendations. These professionals have the expertise to assess the situation and recommend the most appropriate solutions. Secondly, map the DC current flow patterns over time to track changes and identify potential sources. This can help you understand how the current is moving through the ground and where it might be originating. Thirdly, regularly monitor the DC current levels and take appropriate action if they increase. This ensures that the mitigation measures are effective and that the animals are protected. Fourthly, educate farm personnel about the potential hazards of DC current and implement safety measures accordingly. This can help prevent accidents and ensure the safety of everyone on the farm. When using a multimeter, ensure that it is designed for DC measurements. Digital multimeters are generally more accurate and easier to read than analog meters. When taking measurements, make sure to establish a good electrical connection with the ground. Clean the soil or metal surface where you are placing the probes to ensure accurate readings. Also, consider using a clamp meter to measure current flow in buried cables or pipelines without having to cut into the wiring. When installing grounding rods, ensure that they are driven deep enough into the ground to make good contact with the soil. The depth will depend on the soil conditions and the local electrical codes. Spacing the grounding rods appropriately is also important to provide effective grounding. When creating a conductive barrier, make sure that the material is in good contact with the ground and that it extends far enough to redirect the current flow effectively. Overlap the edges of the barrier to ensure continuous conductivity. When applying cathodic protection, select sacrificial anodes that are appropriate for the soil conditions and the level of DC current flow. Regularly inspect the anodes to ensure that they are functioning properly and replace them as needed. When insulating buildings and equipment, use materials that are specifically designed for electrical insulation. Ensure that the insulation is properly installed and maintained to prevent current leakage. When isolating electrical wiring and equipment, use shielded cables and connectors to prevent electromagnetic interference. Ground the shields to provide a path for any stray currents to flow to ground. Remember that soil conditions can significantly affect the flow of DC current. Factors such as moisture content, mineral composition, and temperature can all influence the conductivity of the soil. Mapping the DC current flow patterns can be a complex process, especially in large or complex farm environments. Consider using specialized equipment, such as a GPS-enabled data logger, to collect and analyze the data. It may be helpful to create a visual representation of the current flow patterns, such as a contour map, to identify areas of high current density. If there are underground utilities, such as gas or oil pipelines, in the vicinity of the farm, contact the utility companies to determine if they are using cathodic protection systems. These systems can sometimes introduce DC current into the surrounding soil. Also be aware of any nearby industrial facilities that may be generating DC current as a byproduct of their operations. These facilities may be required to implement measures to prevent DC current from leaking into the ground. Regularly inspect the grounding system on the farm to ensure that it is in good condition and that all connections are secure. Corrosion or loose connections can increase the resistance of the grounding system and reduce its effectiveness. Keep records of all inspections, measurements, and maintenance activities related to the DC current mitigation efforts. This information can be valuable for troubleshooting problems and demonstrating compliance with regulatory requirements. If you are unsure about any aspect of the DC current mitigation process, consult with a qualified professional. They can provide expert advice and ensure that the measures are implemented correctly. Consider the long-term sustainability of the mitigation measures. Select materials and techniques that are durable and require minimal maintenance. Regularly review the effectiveness of the mitigation measures and make adjustments as needed. This ensures that the system continues to function properly over time. Also, be sure to comply with all applicable electrical codes and regulations. These codes are designed to ensure the safety of people and property. If you make modifications to the electrical system on the farm, be sure to obtain the necessary permits and inspections. Document all changes to the electrical system and keep the documentation up to date. If you are selling or transferring ownership of the farm, disclose any information about the DC current mitigation system to the new owner. This ensures that they are aware of the potential hazards and the measures that are in place to mitigate them. Remember that DC current in the ground can be a complex issue, and there is no one-size-fits-all solution. The most effective approach will depend on the specific circumstances of the farm and the nature of the DC current source. Be persistent and methodical in your efforts to find and control the DC current, and you will eventually be able to create a safer environment for your animals and your family. Soil resistivity is a measure of how much the soil resists the flow of electrical current. Soil with high resistivity is a poor conductor of electricity, while soil with low resistivity is a good conductor. Soil resistivity is affected by factors such as moisture content, temperature, and the presence of salts and other minerals. The resistivity of soil can vary significantly depending on the location. Sandy soils tend to have higher resistivity than clay soils. Soil resistivity measurements can be used to help identify areas where DC current is likely to flow. Areas with low resistivity are more likely to be pathways for DC current. There are several different methods for measuring soil resistivity. One common method is the Wenner 4-electrode method. This method involves inserting 4 electrodes into the ground in a straight line and measuring the resistance between them. Another method is the Schlumberger array method. This method is similar to the Wenner method, but the electrodes are arranged in a different configuration. Soil resistivity measurements can be used to design grounding systems for electrical equipment. Grounding systems are designed to provide a low resistance path for fault currents to flow to ground. This helps to protect people and equipment from electrical shock. The size and configuration of the grounding system will depend on the soil resistivity. Areas with high resistivity will require larger grounding systems. Soil resistivity measurements can also be used to assess the effectiveness of cathodic protection systems. Cathodic protection systems are used to protect metal structures from corrosion. The system works by applying a DC current to the structure, which makes it less likely to corrode. Soil resistivity measurements can be used to determine the amount of current that is needed to provide adequate protection.